Richard is cycling at a speed v when he looks at his cycle computer to see how long it will take him to get home at his current speed, and it shows a time of t. So speed equals distance over time, and that means the distance is going to equal v times t. We're later asked in the question, how far from home was he when he first looked at the computer? Actually, that is what we want to calculate. He cycles at this speed for 40 minutes. Right, now the speed is in kilometers per hour, so we need to change 40 minutes into hours. And it's going to be 40 over 60 or 4 over 6 or 2/3 of an hour. So if he cycles at the speed for 40 minutes, then he will actually travel a distance of speed times time, so 2/3 v. Travels 2/3 v in 40 minutes. He then slows down by 1 kilometer per hour and checks his cycle computer. The predicted time to get home at his new speed is still t hours. So after he's traveled 2/3 v, he will have d minus 2/3 v left to travel. Actually, that can be written as vt minus 2/3 v. So this vt minus 2/3 v, the distance left to travel, will actually equal his new speed times the time that it's going to take. And his new speed is v minus 1 because we're told that he slows down by 1 kilometer, and the time taken is still t. It hasn't, because he slowed down, it's going to take longer, and it's exactly the same here. So we create this equation. Okay, I can't solve it because I've got two unknowns, but I can get v in terms of t. So it becomes vt minus t. These cancel out, and we get a very useful result that t is actually 2/3 times v. So I'm going to put a box around that one. Okay, let's continue. He then travels for another 45 minutes, which is 3/4 of an hour. So in that time, he's going to go speed times time. He's going to go v minus 1 times 3/4. So travels 3/4 v minus 1 in 45 minutes. Can then work out how much he has left to travel. He'll have the vt minus 2/3 v from before, and now I'm minusing this extra bit, 3/4 v minus 1 left travel. Can't quite fit it in. Right, so this vt minus 2/3 v minus 3/4 v minus 1, that is going to equal speed times time again. So his new speed is v minus 2, and the time that it's going to take him is still t. And now I've created another equation involving v and t, but don't forget we've got this result here. So it's vt minus 2t. The vt's cancel. I can just times through by minus 1 to make it a little bit nicer. 2/3 v plus 3/4 v minus 1 is going to equal 2t, which is 2 times 2/3 v. I've just replaced t by 2/3 v, substituted in. Now I can work out what v is, then I can work out what t is, and then I'm done because I can work out what d is. So I'm going to multiply through by the lowest common multiple of 3 and 4, which is 12. When I multiply here by 12, the 3's cancel, leaving me 8v. Here, the 12 divided by 4 is 3, so I'm going to get 9 lots of v minus 1. And then I'm going to get 4/3 times 12. The 3 cancels, so I'm left with 16v. So that means 17v minus 9 equals 16v. Therefore, v is equal to 9. And t is 2/3, so a third is 3, t is going to equal 6. And hence finally, d, the original distance, is going to be speed times time, 9 times 6, 54 kilometers. That's how far he was from home when he first looked at his computer. So this is unnecessary, this part here, in terms of answering the question, but I think it's quite good to look at. So he's got 54 kilometers to go, and if you times the speed, 9 kilometers an hour, by 40 minutes or 2/3, then we'll see that actually he goes 6 kilometers in 40 minutes at 9 kilometers per hour. So then he's going to have 48 kilometers to go. No, because he reduces his speed to 8, he can still see why it's going to be 6 hours. Because remember, originally it says it's going to take 6 hours. So he then goes 6 kilometers in 45 minutes because 8 times 3/4 is 6 kilometers. And he's going 8 kilometers per hour. So that means it's going to be 42 kilometers to go. And therefore, he would then go the 42 kilometers in 6 hours at this reduced speed again of 7 kilometers per hour. So you can see how it's all working out with the numbers. It's, yeah, really nice question, and obviously frustrating for him, but he's slowing down and the time is staying the same. But that is what will happen in this particular case. Just finally, I want to share how the official answers go through it. So again, they define the speed to be v and the distance to be d. They write down that distance is speed times time if we were just going the normal speed all the way. And then if we are with the extra bit of information going 40 minutes, so 2/3 v, and then this extra amount, we can write down the total distance here as well. So I started subtracting. That's how my solution differed. We can also write the distance using the 3 different stages. You can combine the first two to give this result that I got earlier on, and then the first and the third gives you this fairly complicated equation, which you can solve to again give v equals 9 and 6. So just a different approach if you prefer.